Okay, so why don't you take a second and try and do the problem. Then after you've given an attempt, we can try and do the problem together. Okay, so pause the video, try it, and then we will continue. Okay, so this says n is a positive integer, and that's basically all the information they give us. So then they have quantity a, which is the remainder when n is divided by 5, and the remainder when n plus 10 is divided by 5. And they want to know which of these two quantities is greater. So one way of going about this is looking at examples. So for example, if you have something like 9, and you divide 9 by 5. Right? So when you divide by 5, you say, how many times can 5 go into 9? Well, 5 can go into 9 one time. Right, 5, and there's a remainder of 4. So then you subtract 9 from 5, and you get 4, and this becomes your remainder. 1 remainder of 4. Alright, so that's kind of an example. Now this is pretty high, this is 4, right? Can you have a remainder of 5? Well, you might think to yourself, well, maybe I can get a remainder of 5 by adding 1 to this, so that now instead of a remainder of 4, I have a remainder of 5. So let's add 1 to 9, and we create 10, and we divide 10 by 5. Now, what changed is that it no longer goes into 9 one time. Now 5 goes into 10 twice. Then you get 10. And then you get a remainder of 0. Alright, so hopefully what this example demonstrated to you is you can have a remainder of 4 when you have something like 9. But you can't have a remainder greater than 4, because the moment you go above 4, you go to 5 left over, you actually just have another of the thing that you're dividing into the larger number. So 5 into 9 goes once with a remainder of 4. 5 into 10 goes twice with a remainder of 0. And you can do this again and again, right? So 11 is 2 with a remainder of 1, right? Dot, 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 all the way up to 14, which is 5 minus 10, which is a remainder of 4 again. Alright, so again, you can have your remainder from 1 to 4, basically. That's what you have for for quantity A. Now let's look at the remainder when n plus 10 is divided by 5. Alright, so then let's take this example. Let's take 19. So 9 was 1 with a remainder of 4. 19 is 9 plus 10. So if we divide 19 by 5, 3, 15. Subtract 15 from 19, and again we get a remainder of 4. Alright, and the reason why is because we actually aren't changing the amount that's left over. We have some amount that you are divisible by 5. So I think visually the way we could look at it is you have, let's say it's something like 14. Let's say this constitutes 14. 10 of this, right about here, 10, is divisible by 5, right? Right, it's divisible by 5. Now let's say you add 10 more to it. All you're doing is you're adding that same amount, and we both know that same amount is divisible by 5. The little bit that's left over is going to be this extra 4. That extra 4 will always be left over, no matter how many sets of 10 you add to a number. You'll always have this little bit extra of 4. So no matter how many times you do n plus 10, the remainder will be the same when you divide by 5. So actually, if you have n divided by 5 has some remainder, we don't know what it is. And if you have n plus 10 divided by 5, it's going to have some remainder. Even though we don't know what it is, it's going to be the exact same as n divided by 5. So the answer for these two questions is going to be B. Both quantities. Oh, sorry. It's not going to be B. It's going to be C. Both quantities are the same.